Oh, I love running around on a train, fascinated by the looks of the most beautiful textures you've ever seen. Oh, I can't wait to see what else this game has to offer. But oh, wait, we don't have anything else to offer yet. Okay, so the last time we've implemented a super fancy parallax background scrolling effect for the train, which essentially acts as our overworld. Now we need to get into the actual game. We are creating a roguelike, which is traditionally characterized by a dungeon crawl through procedurally generated levels. Procedurally generated levels? I guess we have to write an algorithm that generates new dungeons to explore on every run. But how on earth do you make such a terrain gen? I mean, we could theoretically just assign a lot of levels by hand, then pick a random one, but no, that sucks. It's neither procedurally generated nor fun to play at all. You won't have any replay value after playing a few times. We need to come up with a proper system, which, while we are at it, also fulfills certain requirements. The system needs to be flexible. Each generated level should obviously look unique so that new runs don't get boring over time. Artists need fine-grained control over how the output looks like, and the system still needs to be easy to work with. Let's think of a concept of how we could generate a level programmatically. Actually, let's already tackle the latter requirement with a solution that also makes the programming easier. We'll connect pre-designed room templates to still give you a procedural feeling without having to generate the whole room. A lot of games in this genre, like Spelunky or Dead Cells, actually already do this, and it's for a reason. We could use a fully procedural algorithm like wave function collapse, but this way we won't have to care about, for example, the height of a corridor being too small for the player. Let's get back to the room templates. We are using Deep Knight's Level Designer toolkit for designing them, a super easy to use level creation tool that you should definitely check out. It does all the pesky tasks like filling the surroundings with decorations for you and makes designing a lot of levels just much more tolerable. This approach gives us all the customization we need, even on a micro scale. We then only have to import the level files into our Unity project. So let's finish off with a small chunk parser that serializes the level chase into our chunk object. Wow, okay, so many rooms to pick from. Well, we need to start somewhere, so let's pick one that qualifies for being the starting chamber. For that, we can manually label some of the rooms with a starter tag and then pick a random one from the collection. This room should only have one exit, although multiple would work too. The next step is to again pick a random room with the right type and amount of entrances. In our case, this room should have at least two entrances, since we need one that connects to the exit of the starting chamber and at least one that opens a new path, as a two-room dungeon would obviously be too short. But there's an additional thing that we have to be aware of. The more chunks we add, the likelihood of them overlapping each other increases, so let's add a collision check. Okay, so let's repeat all that for every child node, and we can recursively populate the whole dungeon. Once every room in the level graph is placed, we close all the remaining nodes with a single entrance room. And this is basically it. We got ourselves an epic dungeon to explore. Now, there's still a few problems with this approach. With the exponential runtime of the mentioned recursive algorithm, the generator scales terribly. Even though in practice this should rarely ever be a problem, we did a few benchmarks with 400 plus rooms, while a usual level does have at most 100 and it ran smoothly. We should still keep this in mind. There are a few ways to optimize this, for example collision chunking, but that's something for the next video. Another thing not really supported by this algorithm is a circular room graph, where a new path connects to an already existing room. This isn't impossible to do, but we would have to procedurally generate the connection between the two rooms, and the nature of our algorithm just makes this a lot harder. Alright, this has come to an end. The main world generation is done. There's obviously still a lot missing for this to be a fully featured game, but we're lucky that this is a series. So make sure to subscribe to not miss out on the latest updates on this game. And check out the other videos of this channel if you're interested in more indie game dev content.